Next one, difference of two squares. So it's literally what the name says. When we have a difference of two squares, so we have a squared thing and a squared thing, and what does difference mean? It means a minus, so a subtraction in the middle. So when we have the difference of two square things, we use this factorization method. And there's always going to be two terms for this one. So another thing we have to be familiar with here is we need to be able to recognize our perfect square numbers. So what are our perfect square numbers? 4, we have 9, 3 squared, 16, 25, 36, 49, 64, 81, 100. So we need to be able to recognize these, 121, 144, and it wouldn't really go beyond our 12 times tables. So we need to be able to recognize them. 25, we know that that's 5 squared. So the way we do this, if we have a difference of two squares, so something squared and then minus another thing squared, we write two brackets. Again, we're just factorizing it. We're not solving anything, we're factorizing it. So we write two brackets. One of the brackets will have a plus in the middle, the other bracket has a minus in the middle. Now, step 2, the first entry of both of these brackets is the square root of the first thing. So what is the square root of x squared? It is x. Okay, so that's step 2. And in step 3, we take the square root of the second thing. So what is the square root of 25? It is 5. Yeah, because 5 squared is 25. The square root is 5, and that is the second entry. And it's as simple as that. So we write two brackets, a plus in the middle, a minus in the middle. What goes in the first entry of both is the square root of the first thing, and what goes in the second entry is the square root of the second thing. Hands up if that's okay. We'll be seeing another one now in a second. Yeah? And make sure to put down your hands then after so I can see the change in hands. Please. Thank you. Okay, now they can get a bit tougher. Okay, and it's still going to be a difference of two squares, but it can be a bit trickier. So look at this one, 4x squared minus 49. Again, we see that 49, which is 7 squared, it's a perfect square. We see that x squared, so this is leading me to believe it's a difference of two squares. We also have a minus sign in between, and what do we know about 4 as well? 4 is also a perfect square number, it's 2 squared. So again, we know it's going to be a difference of two squares. We're going to write two brackets, we have a plus in one, a minus in the other. Now here's the difficult part. Nothing changes, but it's just what is the square root of this thing? And people will often forget the 4. So we're taking the square root of the full 4x squared. So the square root of that, we take the square root of the number, which is 2, and we take the square root of the x squared, which is x. So our first entry is going to be 2x for both of them. So that's that trick there. If we have a 4x squared, and that's why it's a bit tougher than that one, for that one, the square root of x squared, that's grand, that's just going to be x. But if it's 4x squared, the square root of that, we square root the number to get 2, and we square root the x squared to get x. So that's our first entry. The second entry is grand, the square root of the second thing, and the square root of 49, we know is 7. And that's our final answer. So again, if we were to have, let's say, for an example, if we had 9y squared, what is the square root of that? The square root of that is going to be 3y. Okay, so we take the square root of the number, but we also take the square root of the y squared. Okay, perfect. Now here's another trick kind of question. So that's your second trick, and then this last one. Now, if we look at it, we have a minus sign, we have an x squared, and we have a number. But what do we notice about this 50? 50 is not a perfect square number. It's close to 49, but it's not a perfect square number. So, what can we do here? We know there is going to be a difference of two squares, or hopefully a difference of two squares will pop out, but it's not 1 at the moment, because 2 even isn't a perfect square number. The square root of 2 is like 1.41 or something. So what we can actually do here is use our factorization method number 1. What can we take out of both of these things? Well, we can take out a highest common factor of 2, because 2 divides into both of them. So when we take out that highest common factor of 2, again, we're asking ourselves, 2 multiplied by what gives me 2x squared? We already have the 2, we just need to attach on the x squared. 2 by what will give me minus 50? That's going to be minus 25. Yeah, because plus by minus, we need to get to that minus. And now what do we have? This thing right here is a difference of two squares, because we have a perfect x squared and we have a perfect 5 squared. And this is a nice trick to see. So now what we do, we keep that 2 out, But we know that this bracket here, this can be rewritten as two brackets, right? We're doing the difference of two squares now, where one of the brackets has a plus, one has a minus, and what goes in the first entry? The square root of the first thing. What's the square root of x squared? It's x. What goes in the second entry of both of them? The square root of the second thing, which is 5. And that is your final answer. So that's one to watch for the mock exams. Okay, so originally we were looking at a 2x squared minus 50, but we have the x squared, we have the minus. It looks like a difference of two squares, but 50 is not a perfect square number, 2 is not a perfect square number. And then you recognize, oh wait, there's a 2 that we can take out of both of them. So when we pull that 2 out, we're left with x squared minus 25, which is a difference of two squares. We have a perfect 5 squared and we have a perfect x squared. And then we just apply the difference of two squares.